Hello, hi everyone.
Hello, hi everyone.
Hello, hi everyone. Welcome to the Student Brand. This is our Shiva sir. Today we are going to discuss about light reflection and refraction. Light reflection and refraction. So in this topic, exclusively we will discuss about refraction. Okay, so every time we are discussing about light reflection, now we will discuss about light refraction. Okay, light refraction. So light reflection, light reflection, light reflection and refraction. So refraction. So in this we'll discuss about light refraction. Light refraction. The bending of the light ray at the interference of the two media. The bending of the light ray at the interference of the two media. Or the path of the light changes. The path of the light changes when it is moving from one medium to another medium. If the light ray is moving from one medium to another medium, at the interference of the two media, the light ray changes its direction. The light ray changes its direction. That is called refraction of light. Refraction of light. So a light ray is passing from one medium to another medium. At the interference of the two media, the path of the light changes. The path of the light changes. Okay, so that is called refraction of light. Refraction of light. Refraction of light. So I'm taking this rarer medium. This the rarer medium and this the denser medium. Sir, what is the meaning of rarer medium? The the medium in which the speed of light is more. Okay, speed of light is more. Speed of light is more in the rarer medium, and speed of light is less in the denser medium. So speed is more in the rarer medium, speed is less in the denser medium. Less in the denser medium. When light ray is passing from one medium to another medium, when the light ray is passing from one medium to another medium, the path of the light changes. The path of the light changes at the interference of the two media. At the interference of the two media, the path of the light changes. So that is called refraction of light. Refraction of light. When light rays passing from one medium to another medium, at the interference of the two media, the path of the light changes or bending of the light ray takes place at the interference of the two media is called refraction of light. Refraction of light, 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 the bending of the light at the interference of the two media. The bending of the light at the interference of the two media is called refraction of light. The path of the light changes at the interference of the two media is called refraction of light. So the light ray changes its direction. The light ray changes its direction when it is moving from one medium to another medium. That is called refraction of light. Refraction of light. Understood or not? Refraction of light. So here I am taking the refraction of light. Light is moving from rarer to denser, rarer to denser, rarer to denser, rarer to denser. Path of the light ray changes. Path of the light ray changes from one medium to another medium. The angle between incident and normal line is called angle of incidence. The angle between The angle between incident ray and normal line is called angle of incidence. Angle between refracted ray and normal line is called angle of refraction. Angle between angle between incident ray and normal line is called angle of incidence. Angle between refracted ray and normal line is called angle of refraction. Yes. And one more thing. So here you can observe. When light ray is passing from rarer to denser, it bends towards the normal line. If it is passing from denser to rarer, so this is the normal line. Light ray is moving from denser to rarer, denser to rarer, denser to rarer. Light ray moves away from the normal line. Light ray is moving away from the normal line. Why? Speed of light is increasing in the rarer medium. Speed of light is increasing in the rarer medium. When light ray is moving from rarer to denser, when light ray is moving from rarer to denser, it bends towards the normal line. If the light ray is moving from denser to rarer, it moves away from the normal line. The angle between incident ray and normal line is called angle of incidence. Angle between refracted and normal line is called angle of refraction. And here, so the angle between incident ray and normal line is called angle of incidence. Angle between refracted and normal line is called angle of refraction. In the first case, you need to understand one thing. In the first case, angle of incidence is greater than the angle of refraction. Sir? Why you are saying like that, sir? Why you are saying like this, sir? Why you are saying like this? So when light ray is moving from rarer to denser, the speed of the light is decreasing. That's the reason the light ray is moving towards the normal line. Towards the normal line. Towards the normal line. How? Towards the normal line. If it is light ray is moving from denser to rarer, it moves away from the normal line. It moves away from the normal line. It moves away from the normal line. Yes, so here you can see in the first case, angle of incidence is greater than the angle of refraction. Angle of incidence is greater than the angle of refraction. And coming to the second case, angle of refraction is greater than the angle of incidence. Sir, why? Why, sir? Why, sir? Why, sir? Why? The reason is refractive index. Refractive index. Refractive index at the same time speed of light is decreasing in the rare and denser medium. The first case, speed of light is increasing in the rare and medium. The second case, that is the reason. Yeah, that's why it is bending towards the normal. That's why it is moving away from the normal. And this is about refraction of light. Refraction of light. When light ray is passing along the normal line, if the light ray is passing along the normal line, what happens? If the light ray is passing along the normal line, there is no refraction. There is no deviation. If the refractive index of two mediums, if the refractive index of two mediums are same, so the refractive indexes of two mediums are same, then no refraction takes place. No refraction takes place. Yes. And one more point here you can observe here. This is what? Rarer medium. What is this one? Denser medium. So I am taking this source. Light ray is coming from the source. When light ray is moving from rarer to denser, rarer to denser, rarer to denser, at the interference of the two media, the light ray moves away from the normal line. So the light ray moves away from the normal line. So this is the angle of incidence and this one is the angle of refraction. And so when you keep on sending the light ray, so I'm taking this one. So I keep on sending the light ray. So I'm turning like this. It moves away from the normal. Again I'm sending. It moves. 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 But at certain angle of incidence. At certain angle of incidence. At certain angle of incidence, the refracted ray moves, passes along the surface. Here you can observe at certain angle of incidence, the refracted ray passes or gauges or moves along the surface. The refracted ray makes 90 degrees with the normal line. 90 degrees with the normal line. 90 degrees with the normal line. That angle is called, here you can observe, so I'm taking this one. This is the incident ray and this one is the normal line. At certain angle of incidence, the refracted ray passes or gauges or moves along the surface. So the angle between normal line and refracted ray is 90 degrees. This is called critical angle. Critical angle at a certain angle of incidence. Okay. At a certain angle of incidence, the refracted ray passes, gauges or moves along the surface, are making 90 degrees with the normal line. 90 degrees with the normal line. That is 90 degrees. This angle is called critical angle. Yes. So I am taking one more. The light ray. Light ray is passing from denser to rarer. If the light ray is passing from denser to rarer, okay. If the light ray is passing from denser to rarer, so what exactly happens? In the rarer medium, it makes more than 90 degrees. Okay, it makes more than 90 degrees. Yes. So you have to understand here. This is 90 plus this one is theta. This angle of incidence. At certain angle of incidence, the refracted ray makes more than 90 degrees to the normal line, then it will be reflected back. It is reflected back into the same medium. This phenomenon is called total internal reflection. Total internal reflection. Light ray is moving from denser to rarer. In the rarer medium, it makes more than 90 degrees. It makes more than 90 degrees. Here you can observe 90 plus theta. This phenomena is called total internal reflection. At a certain angle of incidence, the refracted ray passes, gauges, moves along the surface. That angle is called critical angle. The refracted ray passing from the light ray is passing from denser to rarer. If it is makes more than 90 degrees with the normal line in the rarer medium, then that light ray reflect back into the same medium, reflect back into the same medium, reflect back into the same medium. That phenomena is called total internal reflection. Total internal reflection. Yes. Next one we are going to discuss about. We are going to discuss about Snell's law or laws of refraction. Laws of refraction. Are you already for laws of refraction? Laws of refraction. So you can observe here. So I am taking this one. Rarer medium, denser medium. Light ray is passing from rarer to denser. Light ray is passing from rarer to denser. Rarer to denser. This angle of incidence, angle of refraction. So coming to laws of refraction. Coming to laws of refraction. 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 First one is incident ray, refracted ray, normal line. Incident ray, refracted ray, normal line lies on the same plane. Incident ray, refracted ray, normal line lies on the same plane. Next one is the ratio of sine of angle of incidence to sine of angle of refraction equal to constant. The ratio of sine of angle of incidence to sine of angle of refraction constant. That is called refractive index. Refractive index. We have two types of refractive index. Absolute refractive index. Absolute refractive index. And after that, relative refractive index. Absolute refractive index is nothing but ratio of speed of light in vacuum by speed of light in medium. That is called absolute. What is that? Absolute refractive index. Absolute refractive index. Absolute refractive index. What about relative refractive index? Relative refractive index. Speed of light in medium 1 by speed of light in medium 2. Speed of light in medium 1 by speed of light in medium 2 other than air or vacuum. Okay, relative refractive index can be considered as speed of light in medium 1 by speed of light in medium 2. That is called relative refractive index. Relative refractive index. Okay, so that is n equal to V1 by V2. If you are taking N1, 2, that is nothing but N1 by N2, V2 by V1, V2 by V1, N1, 2 equal to N1 by N2 equal to V2 by V1, V2 by V1. This is called relative refractive index. What is absolute refractive index? Speed of light in vacuum by speed of light in medium. Speed of light in vacuum by speed of light in medium. That is called absolute refractive index. Coming to relative refractive index. Relative refractive index. Speed of light in medium 1 by speed of light in medium 2. Speed of light in medium 1 by speed of light in medium 2. That is called relative refractive index. Relative refractive index. You can see here, once everyone look at here, n1 2 equal to n1 by n2, that is nothing but v2 by v1. That also can be right like this. So that is nothing but n21, n21, n2 by n1, v1 by v2, v1 by v2, n2 by n1, that is equal to that is equal to n21 n2 by n1 equal to v1 by v2 v1 by v2 n21 equal to n2 by n1 equal to v1 by v2. Here we are taking relative refractive index. Relative refractive index n12 equal to n1 by n2, that is equal to v2 by v1. n21, that is nothing but n2 by n1 equal to v1 by v2. Coming to absolute refractive index, speed of light in vacuum as speed of light in medium. When it comes to relative refractive index, you should not consider the speed of light in vacuum or speed of light in medium. Speed of light in vacuum are 8. So other than vacuum or A, you can take any medium. Then we can say that is relative refractive index. Relative refractive index. Understood? So done. Next, so we will discuss about spherical lenses. Spherical lenses. So here n21 we can take because v1 by v2 will come n21. Right? Yes. Next one. Next one. Spherical lenses. Spherical lenses. Okay. So here you can see convex lens. Convex lens. Optic center. Optic center. F1 to F1. F2 to F2. F1 to F1, F2 to F2, F2 to F2. This is the part of the sphere. This is the part of the sphere. Optic center F1 to F1, F2 to F2. Okay, so convex lens is also known as converging lens. Convex lens is known as converging lens. Concave lens is known as diverging lens. Sir, why, sir? Sir, why, sir? Sir, why, sir? Because when light rays incident on the lens, it converges the light rays and meet at one point. And I'm coming to the concave lens. When light falls on it, it diverges light rays. When light falls on it, diverge light rays. Those light rays will be diverged. Understood? Diverged. Yes. I hope it is very clear. So, convex lens is known as converging lens. Concave lens is known as diverging lens. Diverging lines. Now, ray rules. Coming to ray rules, 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 ray rules. Dun, 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 dun. Dun, 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 dun. Dun, dun. Ray rules of convex lens and ray rules of concave lens. So everybody be ready for it. So I'm taking the convex lens. This is the convex lens. So optic center, focus, 2f1, f2, 2f2. Light rays coming from infinity. After refraction passes through focus. Coming to the next one. Light rays. Light rays. Optic center f1, 2f1, f2, 2f2. Light rays passing through focus. Light rays passing through focus. After refraction, it becomes parallel to the principal axis. Principal axis. Yes, 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 yes. So here you can see, after refraction, those light rays will become parallel to the principal axis. So here you can observe one more. Light rays, optic center, f1, 2f1, f2, 2f2. So object light rays passing through optic center. Light rays passing through optic center. No deviation takes place. So light rays will not change its path. It moves in the same direction. Same direction. Same direction. Same direction. That is the optic center. Importance of the optic center, sir. What is the importance of the optic center? So, what is the optic center? Importance of the optic center? Well, light rays passing through optic center. To you only I'm saying. Light rays passing through optic center. No deviation takes place. Okay, so this is about convex lens. Convex lens. Coming to concave lens. Concave lens, first one. What is this one? Concave lens. So what is this one? Concave. Optic center. F1, 2F1, F2, 2F2. Light rays passing parallel to the principal axis after refraction it passes through focus. Coming to the second one. Second one. Light rays passing optic center. So F1, 2F1. F2 to F2. Light rays passing through focus after refraction. So that is a concave lens. Concave lens. Understood or not? So I can understand. So you are all are discussing so seriously. Okay, so why to join with our discussion? So that's why. So I'm waiting. So waiting for the right moment to join with our discussions. I hope you can understand. Okay. So Lokya and your name. Ultimate, like that it is there. Okay. So I'll join with our discussions when it is ready to my part. Okay, if my part is there, then I will involve and answer to your questions. Okay. So thank you so much for joining and attending and listening my class. So just if you are interested to the classes, just go and check. So daily classes will be there. Daily live classes will be there. Okay. So check the channel, check the videos. If you like it, so you can join. Outfit. So you want this reason for this outfit. So once check the video, check the my check the channel. Okay. So you can check the channel. You'll get to know. The entire channel is completely related, full of experiments with physics, right? With physics. Okay, with physics only. So full of experiments. Once go and check. Okay, so I can understand. So some people may like or may not. So I thank you for your feedback. So definitely I'll do it. Right? Okay, done. Next one. So I'm taking here this is a concave lens. Concave lens. Optic center. F1 to F1, F2 to F2. So you can wait. I'll sing a nice song for you. So on physics. On physics. Okay, Raju on physics. Oh, thank you. So wait for my song. I'll sing nice song related to physics only. Related to physics only. There are many songs are there. So I converted. I made. So as you said, I cooked physics into songs. So you'll get to know. Wait some time. So here you can see if the light ray is passing through optic center. Okay, so it moves. So I sung one song related to myopia and one more song hypermetropia and one more song sign conventions. Sign conventions. Okay, sign conventions. Thank you so much. So it just happened now. No, it is not now. So right from okay, so right from starting of my channel onwards, so you can check my songs right from starting of the channel 2020. So these are 2026. So almost 6 years. So you didn't trigger me, okay? So I wanted to. I definitely I'll interact with the students, those who came to the live class, those who are listening the live class. When it is right moment, when it is the right moment, right time, definitely I will involve. I will answer. So some people they are no, they will message, right? They will message. They will ask the doubts. That to that doubts also I'll respond. I'll respond. So they will ask doubts in chat. So I'll respond to the questions. So then they will get to know. Those who have asked doubts, for them all I'll respond. They will get to know, right? So I'll respond. Definitely I'll respond. But it depends because once class is going on with a serious mode, high mood, in the peak level, so it continues. It continues. When it is time for interacting, time for involving, definitely I will involve, definitely I will talk, definitely I will interact with you all. So also I will sing one song. So you mentioned one thing, right? Yes, very good. So sign conventions, appropriate sign conventions you have to take, but I will sing one song for you only. Okay, so just check. Look here. So you asked right. I'll sing one song. New Cartesian, New Cartesian, sign convention, New Cartesian, sign convention, all measurements taken from the pole. Distance are positive along the instant trace. Distance are negative opposite to instant trace. Distance are positive above the principal axis. Distance are negative below the principal axis. New Cartesian. New Cartesian, sign convention, New Cartesian, sign convention, all distance measure from the pole. Distance are positive along the instant trace. Distance are negative opposite to instant trace. Distance are positive above the principal axis, distance are negative, below the principal axis. New Cartesian, new Cartesian, sign convention, new Cartesian, sign convention. So I hope it is very clear. So I sung the song. Okay. So like that. So I converted physics content into songs. So it is easy to remember. It is easy to recall. It is easy to know. Okay, so like that, what are the songs I made? All the topics into songs, like two more songs. So for you only because you came to visit and you are watching, right? So for you, I am singing one more song. That too subject only. That too related to this topic only. Related to this topic only, I am doing. That's the reason. That's why I am singing the song. So here uses of lenses. Coming to uses of lenses, also that song comes. So actually, I will sing generally in human in colorful world. When I'm teaching human in colorful world, that time I'll sing this song when it comes to refractive defects. Those are three refractive defects: myopia, hypermetropia. So when it comes to that content, particular to that content, I will sing the songs. But right now, so you all came to visit and see, visit the class. So for you only, I will sing. Right? Let's start. Myopia, myopia, myopia. Myopia, myopia, myopia. Near distance we can see. Far distance we can see. Myopia, myopia, myopia. For that correction we are using. Bro, what bro? For that correction we are using concave lens, concave lens, concave lens, concave lens. So I hope it is very clear. Look, yeah. So did you like it? Okay, if you like it, the content, if you like the channel, if you like the explanation, please do like, share, and subscribe, and share to your friends. Oh, thank you, thank you. So thank you so much. So I'm doing a lot of things like this. So so many are there. So if you observe the channel, if you check the channel, there are many things. So myopia. So we can see near distance, we can't see far distance. For the correction we are using concave lens. So in myopia, we are using uses of concave lens. So for correction of myopia, we'll use concave lens. And coming to hypermetropia. Hypermetropia, 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 hypermetropia. Far distance we can see, near distance we can see. For that correction, we are using convex lens, convex lens, convex lens, convex lens. So like that, understood? So I hope it is very clear. Hypermetropia. So the person who has hypermetropia can able to see only far distance object. He can't able to see the near distance object. But for that correction, we are using convex lens. So in correction of hypermetropia, we'll use convex lens. I hope it is very clear, right? So these are the uses of lenses. Concave lens we are using the correction of myopia. Convex lens we are using the correction of hypermetropia. So those who came to the class, those who understood the concept, those who like the concept, those who like the explanation, so please do like, share and subscribe to Student in the Brand. There are many videos are there, just go and watch. Okay, so if you like the content, if you like the channel, please share to everyone, inform to everyone, share a word regarding the channel. So that is very very important. That is thing I want from you all. I need your support. Without your support, I can't stand here and talk, and I can't stand here and teach. So I can't do all these things. Okay, so for you, with your okay, for your improvement, for yourself, for you only, I'm doing all these things. Okay, so please do like, share and subscribe to Student the Brand. Share to our friends. So just drop one word and share one word regarding the channel, inform to everyone. So let my hard work, let my techniques, let my teaching, let my things, whatever experiments, whatever the ideas, you can say creative ideas and different style of teaching. So let this style reach to everyone. Okay, let this style, let this explanation, let this thing to reach everyone. So okay, so I'm from Hyderabad. So ఎలా ఉన్నారు మరి, అంతా బాగున్నారా? సో ఐ హోప్ యూ అండర్స్టూడ్ మై లాంగ్వేజ్. Hey, Akshita. Okay, Akshita. Hi. So good. Nice. So nice to hear that word. So అందరూ బాగుండాలి, అందులో మనం ఉండాలి. Okay. So come to the point. Next one is so image formations. So we discussed till now ray rules. Now we will discuss about image formations. So this is a convex lens. This is the optic center. F1, 2F1, F2, 2F2. Okay. Object is placed at infinity. First one. Okay. How many light rays are required to form the image of the object? How many light rays are required to form the image of the object? Minimum 2 light rays, right? Minimum 2 light rays are required to form the image of the object. So I'm taking one light ray like this, another light ray like this. After refraction, those light rays will meet at focus. Object is at infinity, image is forming at f2. Nature of the image is real and inverted, and size of the image is highly diminished. So that's the first one. Coming to the second one, so you can see this is a convex lens. Understood? So this is the optic center. F1, 2F1, F2, 2F2. So if the object is placed beyond center of curvature, that is nothing but 2F1. So object is placed So I'll teach only physics. So number of electrical lines crossing through unit cross-sectional area. Okay. So I'm taking this one. If the light ray is passing through focus, okay, and one more light ray is passing through optic center, those light rays here. Those light rays will meet between F1 and 2F1. So here you can see. So this the image. So 2f2. Object is placed beyond 2f1. Beyond 2f1, image will form between f2 and 2f2. Nature of the image is real and inverted. Size of the image is diminished. Size of the image is diminished. Understood? Size of the image is diminished. And coming to the next one. Third one. Object is placed at 2f1. So here I am taking list one. So light ray is passing. Optic center F1, 2F1, F2, 2F2. Understood? So object is placed at 2F1. So image also will form at 2F2. So one light ray I am taking like this, it passes through focus. Another light ray is passing through optic center. Those light rays will meet at 2F2. Okay. Object is placed at 2F1. Image will form at 2F2. Nature of the image is real and inverted. So look here. If you want tips, I want topic. So I already explained. Just watch the video. You'll get extraordinary tips where you need to concentrate, what topics you need to concentrate. Solenoid, so current carrying conductor placed in the external magnetic field, experience the force, right hand thumb rule, Fleming left hand rule, short circuit, overloading, and differences between bar magnet and solenoid. These questions are very very important. And current carrying through straight copper conductor. Okay, so how to identify the magnetic field around the current carrying conductor by using right hand thumb rule. Like this, these questions are there. So once you go and check, already explained the magnetic effects of electric current. So if it is possible at 10:30, again I will take a 10:30 class with a different topic. Now I am explaining light refraction. So at 10:30 I will start magnetic effects of electric current. That is only left. So already completed light reflection and human eye in colorful word. Electric current anyway completed. So light refraction completed. Next we'll go to the magnetic effects of electric current. So I'll explain. If you are preparing, just you can join to the class. Okay, so object is at 2F1, image is at formed 2F2. Nature of the image is real and inverted. Size of the image is same size. Understood? Coming to the fourth one. This is a convex lens. So this is the optic center F1, 2F1, F2, 2F2. Okay, so F2, 2F2. Understood or not? So for grade 12, electric current. Okay, so electric current already explained the chapter. So I'll be starting. So tomorrow I'll start the chapter for grade 12. So already explained the chapter electric current. So it goes on continuously. Yes, ma. So we have this topic 12th. Yes, ray optics it is there. So even in the electric current also for 12th standard electric current topic also already explained. Video is there, you can check once. And for 11th also scalars and vectors, motion in a straight line, motion in a plane. And coming to the laws of motion, so we'll be starting. So maximum concept related questions comes. So rarely they will ask questions. So we can't deny it also. Definitely if they ask problematic question also, they will ask from the chapter. Okay, but maximum based on the rules and based on the solenoid, bar magnet, and so current carrying conductor, related to these concepts only ask. So rarely they will ask about problems. Okay, so problems. So magnetic field, current and length of the conductor. If you want to find out the force, so based on that only. So only one formula. So based on that only they will ask questions. Okay, so if that's enough, maximum that only. Yeah, thank you so much. Yeah, teaching is correct only. So I'll take after this concept. So I'm taking object is placed between 2f1 and f1. One light I'm taking like this. So after that passes through 2f. So 2f1 this is 2f1 and 2f2. Another light ray is passing through optic center. Okay, so image will form here. Object is placed between 2f1 and f1. Image will form beyond 2f2. Beyond 2f2. Nature of the image is real and inverted. Size of the image is enlarged. Size of the image is enlarged. Compared to the object, image size is increased. Compared to the object, image size is increased. Yeah, correct. So coming to the fifth one. Coming to the fifth one. So optic center F1, 2F1, F2, 2F2, F2 to F2. So object is placed at F1. So this object is placed at F1. One light I am taking like this. It passes through focus. Focus and another light ray is passing through optic center. Those light rays will meet at infinity. Object is at f1, image is formed at infinity, nature of the image is real and inverted, size of the image is highly enlarged. So and coming to the sixth one, okay. So sixth one, so lens, so that is a lens. Optic center, that is optic center f1, 2f1, f2, 2f2. So object is placed between f1 and O. One light ray I am taking like this, it passes through focus, another light ray is passing through optic center. If you are extending these light rays, extended light rays will meet extended light rays. Understood? So extended light rays will meet same side of the object. Same side of the object. Just check once here. Object is placed between F1 and O. Image is forming same side of the object. Same side of the object. Nature of the image is virtual and erect. Size of the image is enlarged. Compared to the object, image size is increased. Okay. So these are the image formations. Image formations by convex lens. Image formations by convex lens. Coming to concave lens, only two cases are there. So I thought, okay, so school, college, so you can check my bio. So I have mentioned. And make the channel to reach everyone. So do support in that. Do support in that. School and college also. And coming to the next one. Concave lens. In concave lens only two cases are there. In concave lens only two cases are there. Here you can observe. So optic center F1, 2F1, F2, 2F2. So object is placed at infinity. One light I am taking like this. After that it passes like this. One more light I am taking here. Those light rays are moving away from it. If you are extending this one, Okay, object is at infinity, image is forming at f1. So nature of the image is virtual and erect, size of the image is highly diminished. Only two image formations are there. Only two image formations are there in okay. So concave lens. Only two image formations. One is at infinity. Another one is, so you can see optic center F1, 2F1, F2, 2F2, 2F2. Object is placed. So here you can observe one thing. So the light rays are moving like this. One more light ray is passing like this. If you are extending here, the image will form between F1 and above. F1 and above. Okay, object is placed between optic center and infinity. Between optic center and infinity, image will form. So here you can observe between optic center and infinity, image will form. So between F1 and above, nature of the image is virtual and erect, size of the image is diminished. Compared to the object, image size is diminished. Understood? So this is the first one and second one. Only two cases are there. Only two cases are there. Understood? I hope it is very clear. Next one, lens formula. 1 by f equal to lens power of lens. The degree of converging or diverging of lens achieved is known as power of lens. The degree of, so that's why I will take break. I'll take break. Again, I'll join at 10:30. So all of you can join at 10:30. So again, I'll start a class. Okay, so again we'll discuss. So the reciprocal of focal length. The degree of diverging or converging of lens achieved is known as power of lens. So that is nothing. SI unit of power of lens is diopter. SI unit of power of lens is diopter. I hope it is very clear. So this is about SI unit of power of lens is diopter. Okay, so this is about power of lens, concave lens, image formations, convex lens, image formations, and power of lens is positive for convex, power of lens is negative for concave lens. Okay, so lens formula 1 by f equal to 1 by v plus 1 by u. Oh, yes, you can join at 10:30, ma. Those are okay preparing. So you can join at 10:30. So I'll start magnetic effects of electric current. Next topic, 10:30 topic, magnetic effects of electric current. Join to the class, attend to the class. Okay, so listen to the class carefully and follow the all points. Then practice well. Definitely you'll get good marks. Okay, so now coming to the next one is lens 1 by f equal to 1 by v plus 1 by v minus 1 by u. So that is the lens formula. Magnification height of the image by height of the object v by u. Okay. So in mirror formula plus will come, in lens formula minus will come. So mirror magnification, lens, so no magnification, minus. Okay, in mirror negative magnification, in lens, so positive magnification, that is nothing by m equal to v by u. Okay, so there m equal to minus v by u. Here m equal to v by u. Okay, so okay, I hope you will get. I'll write on the board. So check once. Mirror. This is for mirror and a lens. So mirror formula 1 by f equal to 1 by v plus 1 by u. Lens formula 1 by f equal to 1 by v minus 1 by u. And mirror magnification is minus v by u. Minus v by u, that is nothing but height of the image by height of the object here. So plus v by u, that is nothing but height of the image by height of the object. Okay, so keep in mind, power of lens is positive for convex lens. Power of lens is positive for convex lens. Power of lens is negative for concave lens. Okay, so I hope it is very clear. So these are the points. So it's really awesome, right? So you can verify the concept what I am teaching, whether I am doing correct or not. So you can verify. Okay, so if you have extraordinary knowledge in the concept, so definitely, so check the video whether I am teaching good or not. So so you can listen my classes also. That's enough. Okay. So where we are, lens formula and magnification. That's enough. So I hope it is very clear. So next we will discuss about one more topic, that is magnetic effects of electric current. Join to the class, attend the class, observe the class, listen the class. So you can check with the concepts with the textbook also. Okay. Okay, fine. Okay, so come to the. Okay, done. Fine, no problem. We'll discuss about it. So first, starting with electric current. So grade 12 and grade 11. I'll start with scalars and vectors or laws of motion. So with the topics, I'll start. So okay. So thank you so much. We'll see you in the next class. Join to the class, attend the class, inform to everyone, inform to your friends. So right from 6th standard onwards, people can attend the classes. 6th, 7th, 8th, 9th, 10th, 11th and 12th. So those are attending JE and attempting JE and NEET students can join to the classes. Even I am teaching grade 10, so that will be helpful for them. Okay, so I'll be starting exclusively for a grade 11 separate class, exclusively for grade 12 separate classes. Okay, so thank you so much for joining. Yes, I'll let you know. So tomorrow Monday I'll start. Okay, I'll try. So I'm starting with the electric current now. So already I explained the topic, but ray optics, it will take time because it's going on that one. So I have planned like that. So we'll see if it is possible. I'll start. Okay. So thank you so much, and inform your friends. Ask your friends to join to the class. So spread your one word regarding the channel. Inform to everyone. Ask them to join and attend the classes. Ask them to attend the class. Just listen the class. If they like the channel, so let them subscribe. Okay. So thank you so much. Thank you so much for joining and attending and listening my class. So this is your Sivasal signing off. Thank you.